Hi, in this video I'm looking at this problem here where we've got Alex borrowing $42,000 to set up a takeaway shop she wants to lease. The loan is 9.8% per annum with interest added monthly, and her monthly repayments are $600. We want to first develop the recurrence relation that Alex could use to calculate the amount owing after n number of months, determine how much Alex still owes after 1 year, and if Alex could have secured a loan at 7.9% per annum, how much would she still owe after 1 year of the same repayment? So basically work out how much she would have been saving. So let's do part A first. Part A, the recurrence relation for a reducing balance loan, because this is one, because we have interest being added monthly, but we're also reducing the amount that's in the loan by making repayments. So our recurrence relation is the next period is worked out by doing R times the value at the end of the previous period minus our repayment. So what we want to do is work out what A naught is first, because that's our first period, how much we're starting off with, and that's our $42,000. Our capital R is our repayment, so that's this $600 over here. And lastly, we have little r, which is 1 plus I. But little I is how much our interest rate is as a decimal per period. So we have 9.8% per annum, which we turn to a decimal by dividing by 100. And then we need to work out how much that is per period. We're monthly, so there's 12 months in a year. So that makes little I, we're going to have 9.8 on 1200 as a fraction. It's the easier way of writing it. So we have R is 1 plus 9.8 on 1200. So now to write our final recurrence relation, we're going to have A n plus 1 is going to be R, which is 1 plus 9.8 on 1200 multiplied by an, which we're just going for now just to leave as an, because this recurs, so we've got to make it work for any period. And then we minus off our repayment, 600. And to account for our initial, we say where A naught equals 42,000. So where the initial value is 42,000. So this is our recurrence relation. That's our answer. Each period is calculated by doing this times the previous period minus 600, where the first period is 42,000. Now to answer part B and C, we're actually going to use Excel because we have to do this for 1 year. And that's going to be 12 lots of using this rule over and over and over again. So we're going to switch to Excel and use that to help us work out what our answer is going to be. So we want to make a nice spreadsheet to help us work this out. So to do this, I'm going to put in the same numbers that I have just worked out in my calculations here. So I'm going to list off these A naught, R, I, and then make up the rest of it all as one go with a single calculation. So switching to Excel, we're going to have A naught, which is going to be that $42,000. We're going to have capital R, our repayment, which I'm going to actually label as our repayment, which was $600. I'm going to work out I. Now I required us doing this calculation here, 9.8 divide 100 divide 12. So let's do that calculation in Excel. To do a calculation, we start off as equals, so 9.8 divide by 100 divide by 12. Press enter, and that'll give us the decimal version of this fraction. Then we can do R, which is 1 plus this number. So again, we're going to do a calculation. We're going to have 1 plus this number. So I've just pressed up, or you can click on it to select it, press enter, and now we have R. So now we have all the values that we need to do our recurrence relation we've developed, because we have R, we have R, and we have our initial payment. So now what we're going to do is we're going to have our month, we're going to have the principal, which is how much it starts for, and we're going to have the ending balance, which is how much it's going to finish. So we're doing this for 12 months. So 1, 2, it's enough for Excel to start counting. We're going to go down to 12 months. Now our principal to begin with is our first amount, 42,000. We're just going to type that in there. Now my balance is where I'm going to go to this recurrence relation. I'm going to put in this rule here into Excel. So our rule starts off with equals R times our principal. So equals, now I'm going to go up to R times by our principal. And then it finishes off with minus our repayment, capital R. So I'm going to have minus our repayment, capital R. And so now we've worked out how much is going to be going at the end of the first month. But we need to do this for all months. Now our principal for the second month is going to be this value here. So what I'm going to do is I'm going to go equals that value there, and so that's going to copy it down. And then I should theoretically just be able to drag this calculation down, but it won't. That doesn't look right. And the reason is, if I look at this number here, which is the blue selection, is supposed to be our little r, but it's selecting an empty cell. And this one here, the purple, is supposed to be our repayment, 600, but it's selecting I. This one's fine, it's pointing in the right spot. So what we need to do is stop Excel changing those first two numbers, R and R. And we do that by putting $ in front of the bit we don't want to change. We don't want to change the row it's pointing at. So I'm going to put a $sign in front of the number. And that will tell Excel, I don't want you to update that cell reference. So now if I drag this down, I've got the value at the end of the second year, $41,483.90. So lastly, what I can do is drag all of them down, and this cell is going to grab that cell. Those two are the same, we can see that, and then it's going to bring the rule down, but it's not going to change the bits we fixed. Notice it's still B4 and B2. So then we've worked it out. So at the end of 12 months, so the end of the first year, we still have owing $38,773.64. Now what we'll do to make this a little bit neater, so we can select all of these, make these money. And so now we get it showing all the cents, nicely formatted, and that would be a nice spreadsheet that we can use to calculate this. So let's go and finally answer part B. Part B, determine the amount Alex still owes after 1 year. Well, if we have a look at that, the amount still owing after 1 year, the answer to part B, comes from our Excel spreadsheet. It's this number here, $38,773.68. So $38,773.64. So that's how much Alex still has owing after a year. So she's paid off about $3,300, $3,200 really. So now let's do part C. Part C says that if Alex could have secured a life at 7.9% per annum, how much would she still owe after 1 year with the same repayment? So if we go back to our spreadsheet, well actually let's have a look at our rule here. The percentage, 7.9% per annum, came in this part of our working out here. 9.8% was 9.8%. We then divided it off, added 1 to it and got R. So now if I look at where I did that in my spreadsheet, we did that in I here, where we worked out that 9.8 divided 100 divided 12. So instead of the 9.8, we went 7.9. So let's put 7.9 into there. So that's gone and rechanged everything, because it worked out this 7.9 divided 100 divided 12. That altered R because R was 1 plus that number. It then altered all of our calculations because it was all referring to this number. So we didn't have to do much. And we've got our answer, $37,974.31. So if we change to 7.9%, after 1 year, she only has $37,974.31 still owing. So if she can get 7.9%, she'd end up in a year saving herself almost $1,000. But Excel made those calculations so much quicker and easier.